All right, welcome to The Explainer. Today we're tackling something that literally powers our modern world, but at the same time comes with some pretty incredible risks. We're going to decode a really important new set of safety rules designed to manage one of the most powerful and volatile energy sources out there.
So here's the core question, right? This is the fundamental challenge of what we call liquefied natural gas, or LNG. On one hand, it's an absolute powerhouse for energy. On the other, its physical properties are just extreme. It's colder than the most brutal Arctic winter, and it's flammable. So how on earth do you build and run a massive industrial plant around this stuff without things going very, very wrong?
Well, the answer, it turns out, is a really comprehensive rulebook. A brand new ministerial regulation, which is going to take effect in 2025, basically lays out the entire safety blueprint for Thailand's LNG industry. And this isn't just about, ticking a few boxes. It's about designing safety in from the very first sketch.
So first things first, let's get to the heart of the matter. Why do we even bother with something this challenging to begin with? Well, the answer really boils down to one simple concept: energy density.
Okay, picture this. In its normal gassy state, natural gas is, it's huge. It takes up a massive amount of space, which makes it super impractical to ship across an ocean. But, and this is the magic trick, when you chill it way, way down, it becomes a liquid, and it shrinks to 1/600th of its original volume. All of a sudden, you can pack an incredible amount of energy onto a ship and send it anywhere in the world. It's a total game changer.
And that, of course, brings us to the dangerous side of things. The temperature you need to keep it liquid is a staggering -162 degrees Celsius. That is unbelievably, mind-bogglingly cold. Seriously, any normal material that touches it could just become brittle and shatter like glass. So you've got this incredible power source on one side, but also this massive risk on the other. How in the world do you manage that balancing act? You do it with rules. Really, really detailed, non-negotiable rules. Okay, so let's actually crack open this rulebook. And I want to be clear, this isn't some friendly list of suggestions. Nope. This is a serious, legally binding set of instructions that covers pretty much every single aspect of an LNG facility's life, from birth to retirement.
Now, what's really important here is that Thailand isn't just making this stuff up from scratch. Article 4 of the regulation points directly to something called NFPA 59A, and you can think of that as the global gold standard for LNG safety. It's been developed over decades by experts, so these new rules are standing on the shoulders of proven international experience.
And if you boil it all down, past all the technical jargon, the mission is actually super simple and crystal clear. It cuts right to the chase. The primary job is to keep the public and the environment safe. Period. Everything else in the rulebook flows from that one crucial goal. So how does this all work in the real world? Well, safety isn't something you just bolt on at the end. It starts way before anyone even breaks ground. It's all about the blueprint, where you decide to build, how you arrange all the pieces, and how you plan for a spill before it ever happens. The whole process is really just common sense, but on an industrial scale. It's a step-by-step thing. Step 1, you've got to pick the right location, far away from people. Step 2, lay everything out with plenty of breathing room. Then you build it to be incredibly tough. And finally, you build in backup containment systems, just in case.
And that distancing isn't just a suggestion. The rules lay out exact numbers. We're talking about specific, mandatory buffer zones. An LNG tank has to be at least 200 meters from places like schools or hospitals, and check this out, at least a full 1,000 meters, a whole kilometer, away from large residential areas. These numbers aren't just pulled out of a hat. They're a calculated shield for the community.
Okay, but what if the worst happens and a tank actually springs a leak? Well, the rules have a plan for that too. It's called an impoundment system, and honestly, the easiest way to picture it is like a giant, super strong concrete safety bowl, built around each tank. This thing is designed to be big enough and strong enough to hold every last drop from the tank, keeping any spill contained right there on site. But a great design is only half the battle. Now you have to actually run the place, day in and day out. And that's where the human element comes in, the constant vigilance and the daily procedures needed to keep things running safely.
And this is what that daily safety rhythm looks like. It's not about big, heroic moments. It's about being incredibly consistent. There's a manual for every single task imaginable. People are watching the temperature and pressure gauges 24/7. Every piece of gear gets inspected on a strict schedule. Everyone gets trained constantly, and absolutely everything is written down. It's all about preventing problems before they can even start.
And this isn't a one-and-done kind of thing. Safety is a cycle that never, ever stops. It's this continuous loop, right? You inspect and test everything. Then you retrain and recertify your staff. Then you run a massive full-scale emergency drill. And then you review all your documents and procedures. Then, the next year, you do it all over again. It's about always being ready. Okay, so you've done everything you can to prevent an accident, but you still have to plan for the what if. So let's talk about that final layer of defense, the automated systems and the emergency plans that kick in when something goes wrong. Yeah, it's like having multiple shields, one behind the other. The first line of defense is detection, systems that can sniff out a gas leak instantly. Right behind that, you've got powerful fire suppression systems ready to go. Then, you've got the big red button, the emergency shutdown, or ESD, that can stop the whole operation in a split second. And all of this is backed up by constant alarms and drills, so everyone knows exactly what to do. It's what engineers call defense in depth. And let's be super clear, these aren't just nice ideas. They are hard and fast requirements for specific pieces of hardware. The rules are black and white. You need a high-capacity water supply for firefighting. You need gas detectors in all the key spots, pumps, vaporizers, you name it. And you need those shutdown systems to be totally fail-safe. There's no middle ground. It's 100% of the standard, or it's not good enough.
Okay, we've gone through a lot of technical stuff, so let's zoom out for a second. What does all of this actually mean? What's the big picture for the public and for our energy future?
When you boil it all down, it really rests on these three main pillars. First, there's confidence, knowing that these rules are based on the best global standards. Second, prevention, focusing on getting it right from the very start. And third, protection, having all those overlapping layers of safety. Ultimately, this whole framework is engineered to build trust and give us peace of mind.
So, this regulation is a fantastic step forward for the technology we have today. But it leaves us with one last, really important question to think about. Our world is going to need more energy, not less, and the technology is only going to get more complex. The big challenge for all of us is how do we make sure that the rulebook is always evolving, always learning, and always staying one step ahead of the risks? That's the question for tomorrow. Thanks for watching The Explainer.